Tonight's objective is I can find the area of any polygon by decomposing it into triangles and quadrilaterals. You actually did this back in 6th grade, so tonight should be a reminder of that, and maybe let's look at how we might see it at the 7th grade level. Last night we reviewed finding areas of quadrilaterals and triangles, and tonight we're just going to take any polygon and break it down into triangles and rectangles to find the area. So later in the video, I'm going to find the area of this octagon. But the important thing to remember is we have to be able to break the octagon down into rectangles and triangles, because we know how to find the area of rectangles and triangles. So when I do this problem later, you're going to see me saying, oh, all right, I can break, it's terrible squiggly lines, but right here I've just created a beautiful rectangle. I know how to find the area of a rectangle. I take base times height. Then I can say, oh, right here I have a beautiful triangle. I can take base times height times 1/2 for that triangle. Hey, I've got another triangle right here. Hey, I've got another rectangle here. Oh, look, there's a triangle. There's a triangle. There's a rectangle. So I would actually break this into 1, 2, 3, 4, 5, 6, 7 figures, and then add up all those areas, and I would know the area of the total octagon. So that's kind of where we're going to go with this tonight. Let's take a look at an example. Tyler's garden has 2 sections in it. Find the total area of his garden. Okay, so if I look here, this is a quadrilateral, 1, 2, 3, 4 sides. But you might not know a formula for finding, this is actually a trapezoid. You might not know the formula for finding the area of a trapezoid. Oh, look, and there's another beautiful trapezoid. But what you can do is you can break these trapezoids down. I can break these trapezoids down into a triangle and a rectangle. Now I have these 2 figures. So for this top one, I could do the area of figure 1 plus the area of figure 2. Well, this figure 1 is a triangle. So that first one's going to be the area of a triangle. This second one looks like a 4 by 4 square. It's actually a square or a rectangle, base times height. Okay, but here's the kicker. I'm looking here and I know the base of my triangle, if I slide that 4 up, is just 4 meters. Just want to erase these so I can put down some units. So here, if I slide this 4 up, I can see this is 4 meters along the base of my triangle. And I know my overall height from top to bottom is 7. I also know this height from here to here is 4. The height from here to here is 4. If I slide that over, my total is 7. Oh, the height of my triangle is actually 3 meters because 3 plus 4 gets me to 7. Now I can actually find the area of this triangle. Area of a triangle from last night, you remember, is 1/2 times base times height. So that's 1/2 times the base of our triangle, because the base and height have to meet at a right angle. The base is 4 times a height of 3. All right, so that would be 1/2 of 4 times 3 is 12. 1/2 of 12 is 6. All right, 6 square meters. Meters times meters is meters squared. To that, I'm going to have to add on the area of my square. How can I find the area of a square? Well, you can do the base times the height of the square. Those sides are actually the same. So this will be the base of my square times the height of my square. Just want to show you it's different than that base and height. So the base of my square is 4 meters times the height of my square here is also 4. 4 times 4 is 16. So we have to add our 6 square meters for our triangle plus our 16 square meters for our square. 16 and 6 is 22. 22 meters squared for that portion of his garden. Now, if I was you, I would pause the video and try to do the same exact process for this portion of his garden. If you're not comfortable and you need to just follow along with me, absolutely. If you're feeling comfortable and you can pause the video, try it out and come on back, even better. So this one, I look again and I say, oh gosh, I can totally break this trapezoid down the same way I broke the first one down. I have a triangle and a rectangle. So this would be figure 1. This down here can be figure 2. So this was the area of figure 1. Now I'm going to do the area of figure 2. Figure 2, again, we have an area of a triangle. We're just going to add on to that the area of the rectangle at the bottom of it. Area of a triangle will be 1/2 times the base of my triangle times the height of my triangle. Oops, sorry about that. I jumped a slide. Jumped ahead. Okay. And then to that, we'll have to add on the area of our rectangle. Area of a rectangle, we'll have to take the base of our rectangle times the height of our rectangle. That's the formula for the area of a rectangle. So let's go ahead and look at our triangle first. 1/2 times the base of our triangle is 4 meters. If I slide that 4 up, 4 meters times the height of our triangle. I need to figure out the height of my triangle. This 5 is here just to see if it could throw you off, but the base and height of a triangle have to meet at a right angle. So if I know the entire length is 6 meters, I can slide this over. The bottom length here is 3 meters, 3 and, 3 more. 3 plus 3 gets me to 6. So the height of my triangle must be 3 meters. Okay, so that's 1/2 times 4 times 3 is 12 square meters. Meters squared, half of 12. Oh gosh, that one's 6 too, which is great. All righty, Roo. And then to that, I'm going to add on, I just have to take the base and height of my rectangle. My rectangle. The base of my rectangle is 4. 4 meters times the height of my rectangle is 3 meters. 4 times 3 is 12. Meters times meters is meters squared. 6 and 12 is 18. 18 square meters is the area of figure 2. So what's the area of his overall garden? If he has 2 sections, you have to take the area of figure 1. Add on to that the area of figure 2. 22 and 18. 22, 32, is that 40, I hope? Sounds good to me. 40 square meters for his entire garden. All right, let's jump into that octagon now. And again, you did this back in 6th grade. Hopefully this is just a reminder. Now let's take a look at an octagon. So we have to break this octagon down into rectangles and triangles. And on the first slide, I showed you how I would choose to break it down. First of all, I choose to break it down into this big old rectangle. I'll call that area 1. So we're going to find area 1. Area 1. Area 1 is a rectangle. So to find the area of the first part, it's going to be base times height. Base of my rectangle times the height of my rectangle. So the base would be 1, 2, 3, 4 units long, times the height would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units high. 4 times 10 would be 40 square units. Awesome. All right, I'm going to break it down into some more figures. I'm going to call this figure 2. I'm going to call this figure 3. I'm going to call this figure 4. And I'm going to call this figure 5. And the reason I just took all these triangles and drew them all in at once, because I want you to see Base and height have to meet at a right angle. So the base of this triangle is 1, 2, 3 units, and the height of this triangle is 1, 2, 3 units. Let's take a look at this triangle. The base is 1, 2, 3 units, and the height is 1, 2, 3 units. Oh, this is looking good. Base of this triangle is 1, 2, 3 units, and the height is 1, 2, 3 units. The base of this triangle is 1, 2, 3 units, and the height is 1, 2, 3 units. So the really nice part about this, if I have to do areas 2, 3, 4, and 5, if I want to find areas 2, 3, 4, and 5, all of those are triangles that have a base of 3 units and a height of 3 units. And how many of those do I have? 1, 2, 3, 4. So to find the area of figures 2, 3, 4, and 5, I'm going to write down the formula for my area of a triangle, which is 1/2 times base times height. That's going to be 1/2 times my base of 3 times my height of 3. The base was 3, the height was 3 on each of those. So that's going to be 1/2 of 9. 1/2 of 9 is 4.5. So that's 4.5 units squared. And the nice thing is there's 1, 2, 3, 4 of those. So guess what? All I have to do is take 4.5 to find the area of all of those areas. I just take, there's 4 matching triangles. Each of those triangles has an area of 4.5 square units. So you just take 4 times 4.5, and I believe that should get you to 18. I hope I am not making any mistakes here, because I figure if I double 4.5, it's 9. 9 times 2 is 18, so 4 times 4.5 should be 18. All right, so now I have to just worry about areas. We were up to, this could be area 6 and this could be area 7. Let's take a look. Area 6 is a rectangle and it has a base of 1, 2, 3 and a height of 1, 2, 3, 4. Hey, area 7 has a base of 1, 2, 3, a height of 1, 2, 3, 4. Awesome. So it looks like if I want to find my areas for figure 6 and figure 7, those are both rectangles. And it looks to me like the base of each of those rectangles is 3 units. They're both rectangles with a base of 3 units and a height of 1, 2, 3, 4 units. Oops, sorry, we're never getting to this problem tonight, so no worries on that. And it looked like the height was 4 units. So the height of that rectangle was 4 units. So to find the area of each of those, I just do base times height for the area of a rectangle. The base was 3 units. The height was 4 units. 3 times 4 is 12 square units. However, there's 2 matching shapes like that. So to find the overall area for both shape 6 and 7, I would do 2 times 12. 2 times 12 is 24 square units. And now I know when I broke it down, figures 6 and 7 was 24 square units. Figure 1 was 40 square units. And figures 2, 3, 4, and 5 had a total of 18 square units. So to find the overall area of this octagon, I just add those up. 40, 18, 24. We're going to go ahead and add those up. 8 and 4 is 12. 4 and 1 is 5, and 1 is 6, and 2 is 8. Let's hope I added that correctly. As long as I did, the overall area for this octagon is 82 square units. All right, that's a little review for finding the area of any polygon. Hopefully that helps.